In this video, we'll configure the SureServo2 system using position register mode to have this linear slide go over here, wait a second, go over here, wait a second, and then repeat that operation over and over. That'll be enough to give you a quick look at how to set up paths in position register mode. Understand that position register mode is really two parts. There's the command portion, where you tell the drive what you want it to do, and the control portion, where the drive does everything it can to maintain the position, speed, and current, and apply that appropriate signal to the motor. This video is all about the command side, where we tell the drive what to do. In position register mode, you can set up to 99 commands, or paths, plus homing. Homing is a big subject all by itself, so we'll cover that in a separate video. You can select and/or trigger each path via digital inputs, events, manually by writing to register 5.07, from a capture, a compare, electronic camming, communications, or Ethernet IP, which is a special case of communications. Triggering is also a big subject all by itself, so we'll cover that in another video. So understand the significance of all of this. For comparison, the original SureServo has only 8 internal index positions, or paths, and can only be triggered by digital inputs or comms. Just another example of why the SureServo2 is such a tremendous value. Again, more features, lower price. For this video, we'll manually trigger the first path, which will automatically take us to the next path and the next until we hit a path that tells us to circle back and do it again. Each of these can use any of 15 possible delays, acceleration and deceleration ramps, and speeds. You can also set up electronic gearing and apply an S-curve to smooth transitions between the speeds and various kinds of filtering. In this video, our focus will be on setting up the paths using the default values provided in these tables. Once you see how to set up the paths, you can then check out the other videos on all of these guys. So for our quick demo, let's tell the servo system to move to absolute 0, then move to the right of 0 around 3 inches, wait a second, then to the left of 0 roughly 3 inches, and wait a second, and then go back to path 2 to repeat that indefinitely. Each path will pull the delays, the acceleration and deceleration ramps and speeds from these tables as needed. Let's do it. I'm using the same hardware setup as we used in the quick start video, so I won't take the time to repeat that here. The only difference is I connected the SureServo2 motor to this IGUS linear slide to give us something to look at. I'm going to go to parameter 2.08 and enter a 10 to do a factory reset so you know exactly where I'm starting from. And we always do a power cycle of the drive after a factory reset just to make sure any residual values get cleared out. Let's enable the servo motor and go to parameter 4.05 and jog the slide to the center. And exit jog, and kill the servo motor. We could configure the position register paths from the drive's keypad, but it's so much easier to do it with the free SureServo2 Pro software that you can download from AutomationDirect.com, because it takes care of all the little details for you. There's a separate video showing you how to use the SureServo2 Pro software, so we're just going to jump right in. The factory reset power cycle broke my communications with the drive, so just hit this to reconnect. I'll expand this settings menu, and under the top level settings is where you choose the mode. We want the position register mode. This looks a lot like our block diagram, doesn't it? Here's the command portion, and here's the control section. Now don't forget to write the new mode to the drive. If your path doesn't work, then come back here first, click on Read Parameters, and make sure you selected the PR mode. It's really easy to forget to write this to the drive. And we always power cycle the drive after changing modes to make sure everything gets initialized correctly, which means we lost our connection, so I need to hit this to reconnect again. We don't need to fool with any of this, but let's modify the electronic gearing like we did in the quick start video with 10,000 pulses per revolution. That's more than enough for what we're doing. Now this is important. Setting it here doesn't get it to the drive until you actually write it out. Well, now we just go down to the motion section and select the PR mode. Here are the 15 ramp times that we can use for either acceleration or deceleration, the 15 delay times, and the 15 target speeds. These defaults are fine for this demo, but you'll want to enter whatever numbers you need for your system. In this section, we can set the electronic gear ratio, software limits, auto protection, and event triggers. You can see the electronic gearing is at the 10,000 pulses we set it to earlier. So we could have done that right here, I just wanted to show you there are multiple places to do things. We're covering homing in another video, so now we just go to the path settings. Notice there is no path 0. That's reserved for the homing path. If I click on path 1, we get this empty form to fill out. We want our first command to go to absolute 0, so that's a point-to-point path, and we want it to automatically transition to the next path when it's done. When we do that, we get a bunch of options to choose from. We're not going to worry about interrupting or overlapping commands, and we want this to be an absolute move. You can also move relative to where you are, incrementally add to where you are, or use capture data to determine your next move. Down here, we set up how the move will go. This guy pulls from the 15-line ramp table, 200 milliseconds is fine for now, and a deceleration pulls from the same table. Let's grab 500 milliseconds for that one. The speed pulls from the speed table. Again, we'll just grab one of the defaults. I know around 2000 RPM will work fine for this slide. Now, did you see the ramp time change? Remember, the ramp times selected are the time to go from 0 to full rated speed, which for this drive is 3000 RPM. Since we're only going to 2000 RPM, or 2/3 of the way, the acceleration time is 2/3 of the total. I love that the SureServo2 software calculates that for me. And we don't want any delay after this initial command, and we want to go to an encoder count of 0. I'll hit the download button to send this path to the drive. The second path is just more of the same. We want point-to-point with auto advance. All of this will be the same, and we want to change the speed to 2000 RPM again. But this time, let's pause for 1 second when we get to our destination. This linear slide moves about 1/5 of an inch each revolution, so we need 15 revolutions to get 3 inches, and we set the electronic gearing to 10,000 pulses per revolution, so we need to issue 150,000 pulses to move 3 inches. So I'll put that here. And download this path to the drive. Yeah, I know I can write all the paths once here or here. It just makes me feel better to do each one individually. For path 3, everything is exactly what we just did in path 2, except now we want to go to minus 150,000 pulses. Remember, this is an absolute move, so it's going to go until the encoder reads minus 150,000, which is actually a 6-inch move. If this was a relative move, then it would move 150,000 pulses relative to where we are, so it would only have moved 3 inches. So always make sure the pulse count jives with whatever type move you've selected up here. And I love that I can document each step if I want to. And I'll write that one to the drive. For path 4, we want to jump with no delay back to path 2 and write that one out to the drive. Now look at this. The software draws a little diagram of how things are going to proceed with this little blue line. The path will start at step 1, and when it hits step 4, it'll jump to step 2. If I change path 2 to a simple point-to-point with no auto advance, the blue line says to stop after this step. And I'll change that back and write it out to the drive. This number 3 tells you which one of these the move will use. Well, that's it. I'll reach over and enable my servo motor and get the display to show the encoder count. To execute the path, I just say I want to start at path 1 and hit this. And sure enough, the slide goes to the right of 0.3 inches, pauses for a second, then goes to the left of 0.3 inches and pauses for a second, and repeats it over and over and over. I can also bring up the scope that I've already configured to show the motor speed in purple and the path in blue. We cover how to use the scope in a software video, but I wanted to remind you it's here, and it's an invaluable tool when you're trying to debug these things. For example, remember the software told us the actual ramp time was going to be 133 milliseconds? Yep, sure is. Cool. Notice that the actual path command is shown for each path. That helps you understand how these paths are put together. To stop the path, just hit this. You can also force the servo on using this guy instead of the manual switch. Well, that's the basics of setting up and testing paths using a manual trigger. And all we really did was enable position register mode here, modified the electronic gearing here, and entered our paths here. When we hit this button, it simply took this path number and sent it to parameter 5.07 to manually start the path. We could have gone to parameter 5.07 and done that ourselves. This is just easier. The next thing to do is to set up the actual trigger you want to use in your system. We'll learn how to use all of these triggering methods in the next video. Meanwhile, click here to learn more about the SureServo2 system, including where to find more videos. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.